Hello, this is Schedulytics. Welcome to today's session. In today's brief video, we're taking a look at the concept of paired sample t-test. We will demonstrate this using JASP, and as we do, we'll come to appreciate its statistical application. Paired sample t-test. Well, it compares the means between two related groups on the same continuous dependent variable. How do we mean? Let's assume that you have an intervention group and you want to look at their height, for example, at baseline, and then their height again after the intervention end line. Now, you've obtained your values or the height value or measures at baseline as well as end line. You now want to know if there's a statistical difference between these two measures. Whenever you seek to do such a thing, you need paired sample t-test because this is a matched data or a repeated measure on the same group. Now, there is a null hypothesis that is tested for when we are doing paired sample t-test. And that hypothesis states that the pairwise difference between the two groups is 0. That is to say, in this example, the height at baseline is not different from the height at end line. Hence, the baseline and the end line measures of height is statistically the same. Now, there are some assumptions that are made whenever we are undertaking a paired sample t-test. And one of them is that the dependent variable should be measured on a continuous scale. Another is that the independent variable should consist of two categorical related or matched groups. The third one is that the difference between the matched pairs should be approximately normally distributed. Now, since these data sets are continuous variable, we need to also undertake or perform a normality test on them. Whenever we perform a normality test and one is parametric, or the parametric set of data sets have a different form of analysis compared to those that turn out to be non-parametric or not normally distributed. Now, having established the theoretical basis for paired sample t-test, we now want to demonstrate it using JASP, and there we would see the names of the tests that we can use or apply whenever we know that our data set is not normally distributed or is normally distributed. At this point, let's go to our JASP platform and demonstrate how we can perform paired sample t-test. Perfect. So we are now on our JASP platform. So we'll click here as usual. I'll come to open. Then we come to data library. We go to test or t-test, and then we try to scroll down to see where we can find a data set that would help us perform paired sample t-test. And voila, on this particular data set, we have a JASP file that would help us demonstrate the use of a paired sample t-test. So we click on this, and within a few seconds, our data is loaded. We wait a while for the description to appear. Yes, it has appeared over here. So now, this is a data on moon and aggression, a paired sample t-test. Now, this is the description of the data. It says that this data set, moon and aggression, provides the number of disruptive behaviors by dementia patients during two different phases of the lunar cycle. Each row corresponds to one participant. Now, the variables that are considered here includes the moon, which is the average number of disruptive behavior during full moon days, and then the average number of disruptive behavior during other days. Now, notice here that the null hypothesis that is being tested for reads. The null hypothesis which states that the average number of disruptive behaviors among patients with dementia does not differ between moon days and other days. So it's clear. The null hypothesis is that there's no difference between what happens to dementia patients at moon days and that of other days. So when we test this and we realize there's a difference, then we'll reject the null hypothesis. However, if we realize there's no difference, then we fail to reject. Notice we didn't say accept. We fail to reject the null hypothesis. So we load our data set. It's already loaded here. If you want to load, should there be no variable here, you just click here and then it comes. So we send it back because we already have it loaded already. Then you check this. Well, first of all, we want to check the normality assumption. So once we click on normality, the check assumption form, we look at whether our data set is normally distributed or not. Now, the Shapiro-Wilk normality test says that the p-value is statistically insignificantly different from what is normally distributed. Hence, we can conclude that our data set is normally distributed. And since it is normally distributed, we go with the student or the student test, which is the paired sample t-test, which we'll be using. However, should it be not normally distributed, in that case, we can say it's non-parametric. Then we'll have to use this Wilcoxon rank or sign rank test instead of using the sample t-test. So these are the dichotomies or the differences that, or the variations that occur whenever we are trying to undertake test statistics. We first have to establish whether it's normally distributed or not. If it is normally distributed, we go for this. If it's not normally distributed, we go for that. Now, running our test, it helps us to see here that the p-value is statistically significant. That is to say, it is less than 0.05. And since it is less than 0.05, and the mean difference here is 2.43, looking at the mean distribution of the two groups, the moon is 3.02, and then the other is 0.959. So by visual inspection, we can say that this is greater than this. And statistically, or the paired sample t-test has also shown that this difference we are observing visually is statistically significant. Hence, we reject the null hypothesis. We reject the null hypothesis. Good. So basically, this is how we undertake paired sample t-tests. Hope you find this video useful. We encourage you to watch it over and over and to really comprehend what we are trying to push across. If you have any comments, if you have any suggestions for improving this video, kindly put them at the comment section. And please don't forget to subscribe. Don't forget to like, and please share with as many as possible people that you know would benefit from this. We are trying to push an agenda, and we hope thousands of people come to really benefit from having to appreciate statistics and not have difficulties. Until we meet again, it's a bye.